In the world of modern software, microservices need to talk to each other. But what happens when service A sends a request to service B and service B is currently down? This is the problem of tight coupling. If your system relies on direct HTTP calls for everything, a single failure can trigger a cascading outage across your entire infrastructure. Enter the message queue. Think of it as a buffer or a post office for your data. Instead of talking directly, Service A, our producer, sends a message to the queue. Service B, the consumer, picks it up whenever it's ready. This simple abstraction introduces decoupling, allowing systems to scale independently and handle traffic spikes without breaking a sweat. Today, we are exploring the two giants of this space, RabbitMQ and Apache Kafka. They might look similar, but their internal architectures are fundamentally different.
Let's start with RabbitMQ. It is based on the AMQP protocol and is often described as a smart broker. In RabbitMQ, the producer doesn't send messages directly to a queue. Instead, it sends them to an exchange. The exchange is like a mail sorter. It looks at the message's metadata and decides which queue it should go to based on predefined rules called bindings. This gives you incredible flexibility. You can do fan-out, where one message goes to every queue, or direct routing based on specific keys. Once a message is in the queue, RabbitMQ tracks its state. It waits for the consumer to acknowledge that the message was processed. Once acknowledged, the message is typically deleted from the broker. This makes RabbitMQ excellent for complex routing and ensuring that every individual task is accounted for in real time.
Now, let's look at Apache Kafka. Kafka isn't really a queue in the traditional sense. It's a distributed transaction log. In Kafka, messages are organized into topics. Each topic is divided into partitions. When a producer sends a message, it's appended to the end of a partition and assigned a unique ID called an offset. Unlike RabbitMQ, Kafka doesn't delete messages after they're read. They stay on disk for a set period, like 7 days. This is the smart client model. The broker doesn't care who has read what. Instead, the consumer keeps track of its own position by remembering the last offset it processed. This architecture allows Kafka to handle massive throughput because it's just writing to the end of a file. It also means multiple consumers can read the same data at their own pace and even rewind to reprocess old data. The biggest architectural difference is the delivery model. RabbitMQ uses a push model. The broker actively pushes messages to consumers as soon as they arrive. This is great for low latency. Kafka uses a pull model. Consumers ask the broker for messages when they have the resources to process them. This prevents consumers from being overwhelmed during traffic spikes. Think of RabbitMQ like a phone call. The information is pushed to you immediately. Kafka is more like a DVR. The show is recorded and you watch it whenever you're ready, at your own speed. This makes Kafka the gold standard for big data, log aggregation, and event sourcing, while RabbitMQ shines in task queues and real-time messaging between microservices.